Hi, welcome to today's Statics of Solid Mechanics tutorials. In today's tutorial, I will take you through determining the magnitude and direction of the resultant force using parallelogram law of forces approach. My name is Adam Gatogo. Thanks for joining me. Now, given this parallelogram ABCD, we are saying that alpha here, gamma here, beta, theta, and phi are all angles. And then the F1 force here and F1 force here, they are parallel to each other. Likewise, the F2 forces are also parallel to each other. And R is the resultant of F1 and F2 forces. Now, any two adjacent angles are supplementary. Thus, their sum is 180. That means when you add this angle here plus this angle here, you should get 180 degrees. So alpha plus theta, which extends to this C, this force F2, theta is the angle between this force F1 here and then the other force F2. So theta plus alpha should give you 180 degrees. Now, by cosine law, the magnitude of the resultant force R is given by R equals to the square root of F1 squared plus F2 squared minus 2 times the product of F1, F2 cos alpha. Alpha is the angle between the force F1 and force F2, and theta is the angle adjacent to alpha. So when you want to use the angle adjacent to the angle between the two forces, that's alpha, then your magnitude, the magnitude of your resultant becomes R equals to root of F1 squared plus F2 squared plus 2 times the product of F1, F2 cos theta. Now, by sine rule or sine law, F2 over sine beta, F2 here over sine beta should be equal to R over sine alpha. And then that should also be equal to F1 over sine gamma. That's by sine rule. Now let's take a look at this question and solve it. The question reads, determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis using parallelogram law of forces approach. Now this is our diagram. We've been given two forces, F1 equals to 800 Newton force, then F2 equals to 600 Newton. And using the diagram we have been given, we can form a parallelogram out of it. And so you start by the 800 Newton force, and then the starting point, the ending point of the 800 Newton force should be the starting point of the 600 Newton force, which forms 30 degrees to the horizontal. So you carefully place it there, and then you draw to form your parallelogram. When you do that, you realize that the 600 Newton force is parallel to the 600 Newton force here too. So it will also extend 30 degrees from the x-axis. And so when you do that, you know that from here to this point on the plane is 90, and plus this 30, that one would have given you the angle theta here. So 90 plus theta plus 30 equals to the angle theta. So 90 plus 30 equals to 120. And now the alpha here, you also know that here is 90 degrees. So the 30 that the 600 Newton force extend from the x-axis plus alpha should give you 90. So when you subtract 30 from 90, it should give you alpha, and alpha equals to 60 degrees. Now, by cosine law, r squared should be equal to the f1 force squared plus f2 squared plus 2 times the product of f1 and f2 cos theta. Because we are using an addition, we have to use cos theta. So when you slot in your values carefully, you know the f1 force will be 800 Newton. So r squared equals to 800 squared plus 600 squared. That's the F2 force plus 2 times the product of F1, F2, which is 800 times 600 cos 120 degrees. And when you punch your calculator very well, you'll get the r squared to be equal to 520,000. And then when you take square root of both sides, then you get the value of r to be equals to 721.1103 Newton to be the magnitude of both the F1 and then the F2 force. Or when you don't want to use the angle cos, the angle theta here, you can use the angle alpha between the two forces, and that angle is given to us to be 60. And when you slot in the value of alpha into the equation, then your r squared becomes 800 squared plus 600 squared minus 2 times the product of 800 and 600 cos 60. Then when you punch your calculator well, you will get the value of r squared to be 550,000 Newton. Then when you take the square root of both sides, you get the magnitude of r, the resultant. The magnitude of the resultant will be 721.1103 Newton. So you could either use this formula or this formula. Now, we are looking also for the direction of the resultant force measured counterclockwise from the positive x-axis. Now, looking at our diagram, from the positive x-axis to the resultant here is phi, is the angle phi. So we are looking for the angle phi, but we cannot easily find that. But we can start with the ones we know. From sine rho, we know that r over sine alpha, r here over sine alpha should be equal to the 600 Newton force here over sine beta, because beta is the angle between this F1 force and then the resultant. So we are using triangle ABD. Triangle ABD. When you take that, you realize that alpha is the angle between the F1 force and then the resultant. So by sine rho, r over sine alpha should be equal to 600 over sine beta. Now you know the value of alpha to be 60 degrees, and then r is also equal to 721.1103 Newton. Now, when you slot in those values, you realize that it will make first sine beta equals to, making sine beta the subject, you realize that sine beta equals to 600 sine alpha all over r, and then beta is equal to the sine inverse of 600 sine alpha all over r. Now you now slot in your values, you know that beta will become sine inverse of 600 times sine 60 all over 721.1103. Then when you punch your calculator well, you'll get beta to be equal to 46.1021 degrees. That is the value of this angle beta. Now you know that beta plus alpha here should give you 90 degrees. Beta plus alpha should give beta plus phi. Beta plus phi should give you 90 degrees. And so when you subtract the value of beta from 90, you should get the value of phi, which is the angle the resultant make with the positive x-axis. So 90 minus beta, which we have just calculated to be 46.1021 degrees. When you subtract it from 90, you get 43.8 43.8979 degrees to be the value of phi. Or you know that theta equals to 120 degrees. Theta equals to 120 degrees, and theta is also equals to the 30 degrees here plus phi plus beta. Beta plus phi plus 30 degrees should give you the value of theta, which is 120. And so when you make theta phi the subject of that equation, you get phi to be equal to theta minus the 30 degrees plus beta. And then when you slot in the value of theta, you get 120 degrees minus 30 degrees plus 46.1021. Then when you punch your calculator very well, you will get the value of phi to be 43.8979 degrees, and that is the angle the resultant made with the positive x-axis.